2 June 2016, Part 2, Section 8.2.
Let's resume the class. So the next thing is we're going to find the slope. So why we need the slope? So let's look at the following. So the linear equation or the straight line looks simple, but we need to know some property. And one of the properties is x-intercept and y-intercept. So when the linear line or the straight line intersect with the x-axis or y-axis, we have to know that. And the second, maybe third important thing is we have to know the stiffness of this linear equation, linear line. The stiffness tells us, well, how stiff it is, basically, and we call that as the slope of the linear equation. So this tells us the stiffness. So the slope is the measure of the stiffness of a line, and that is called the slope of the line. So for the linear line, we need to know the slope of the line, and we need to know the x-intercept, and we need to know the y-intercept. These three things, we have to know that. Now, how can I define the stiffness? The stiffness is a ratio between the x increase and y increase. When you have a 2 point when you connect them, and let's say this point is x1, y1, and this point is x2, y2, and for the stiffness, we draw the two lines, auxiliary lines, and this is the same as like a right triangle. This is exactly the right triangle, and for this point is, we don't need this point, but this point is the same as x2, y1. The y value is the same as this point. X value is the same as the second point. So that is x2, y1. And this length is x2 minus x1. And this length, where the height is y2 minus y1. Now slope is defined as the ratio between x2 minus x1 and y2 minus y1. So ratio determines the stiffness. For example, the x increase is really small, but y increase a lot. Then there is a really huge stiffness, right? Like x increase only about this amount, but y increase like that. Then when you draw the straight line of these 2 points, it is a lot steeper. Then x increase really a lot, but y increase really small. That. It has almost tiny bit of stiffness, and this has somewhat like a large stiffness, right? So depending on the ratio of these two values, x2 minus x1 and y2 minus y1, and we can define the slope of the linear line. The slope formula is the following. So if the x1 and x2 are not the same, the slope m of the line through the distinct point x1, y1 and x2, y2 is defined as m is equal to change in y value over change in x value. The y value, the change in y value is this, y2 minus y1. Change in x value is x2 minus x1. And this is the slope. Slope m is this. Now you can switch the y1 minus y2 over x1 minus x2. It's the same thing. Yep.
All right, help me understand. When I'm looking at y2 minus y1, I'm used to that being a point. Now it's 2 points, 2 different points. How is y 2 different points?
Because we have a 2 point, x1, y1, and x2, y2. This 2 point. This point is x1, y1,
right.
And this is x2, y2. We have a 2 point. So by using these 2 points, we can draw the line, straight line. Now we are going to find the stiffness of this line, which is a slope. So to define the slope, we use the ratio of the y increase over the x increase.
Where is 0 on that graph right now?
It doesn't need to be.
Yeah,
it can be any point, anywhere.
So x2 minus x1 means 1 dot right there.
What in the 1 dot? This is not dot, this is a distance between this point to that point.
Right.
For the x value. y2 minus y1 is the distance from this point to that point.
So you basically, x is 2 points to the left, and then you're going all the way back to 1 or negative 1? When you
We'll discuss the example on the next slide. So it may be much more clear.
Okay.
So the slope is a y increase over the x increase. Well, many people say, some people say that the rise, this is a rise, right? Because that is the increase. Rise over run. You can say that, but, that depends on the textbook. So if you like, you can say that rise over run. Rise is a y change, run is x change. Now let's see, we're going to find the slope of the line that passed through the point 2, negative 1 and negative 5, 3. We don't need to plot the point, but if you like to plot the point, we can do that, although we don't need to at all. 2, negative 1 is 2, negative 1, this point. is a 2 comma negative 1, and negative 5 comma 3 is about this point is negative 5 comma 3. So when you connect that, that should pass through the point. Anyway, then we will find the slope of this. So to find that, we can make a right triangle in this way or in this way. It doesn't matter, that's the same thing. So for the slope is y change, or the change in y, over the change in x. Well, let's think about the arrow in this way. So x is increasing, but y is decreasing, right? So x is changing from negative 5 to 2. How much does it change? 7. So how can I get 7? Which is 2 minus negative 5. That's a 7.
But you just took those numbers random, or?
No. That is a given point. Negative
Oh, right,
5 and
negative
2.
5.
That's a given.
Yeah, but the minus sign.
Because the difference or the distance is you have to subtract. Like the distance between the one point, like the x equals 1 and x equals 4 is, you subtract 4 minus 1. That's the distance. Or that's the change. Now for the y change, or the change in y is, we move from this point, or this value to that value, which is from 3 to negative 1. From 3 to negative 1. How much does it change?
The absolute value of 4,
No,
right?
just how much from 3 to negative 1. From 3 to negative 1. Well, that's not. So from negative 1 to 3 is a plus 4. We got a plus 4. Plus 4 is we increase. But this is a decreasing case. Right? So decrease of 4 unit. Decrease 4 unit is negative 4. So negative 4 is the same as negative 1, which is this number, y value, minus this number, 3. So which is negative 4 over 7. And this is a slope. And slope is the stiffness of this. When this number is a negative, the stiffness looks like this, always. So always looks like this way. When this stiffness is positive, the graph always looks like this way, when this slope is positive.
Why wouldn't you just plug in to that equation?
Yeah, you can plug in. You can plug in y2 minus y1 over x2 minus x1.
Then you get positive 4 over negative 7.
Yeah.
Does that matter?
That's what I got.
That's the same as 4 over negative 7.
Okay.
It doesn't matter. Any other question? Okay, so let's move on. Positive and negative slopes. A line with a positive slope rises from the left to right. So that is, a positive slope looks like this. Then a line with a negative slope rises from right to left. So it looks like that. That is a slope negative. The slope of parallel lines. The parallel line means they never meet with each other. They always keep the same distance. So two non-vertical lines with the same slope. So they have to have the same slope. Then we say that they are parallel. There are many of these, right? Like a parallel line. So like this kind of a table, this line is parallel to this line, typically. Or when you think about the railroad, they're always like a parallel. Otherwise, there is a crash. So that is a parallel line. When they have the same slope is a point, and they are parallel. So, for example, like the y is equal to 2x minus 5, and well, we will see that y equals like the 3x minus, y equals 2x minus 6. So this, the first number, the coefficient of this, x value, and that tells us the slope of the line. And when they are the same, we say that the two lines are parallel. So the parallel line is when y is equal to ax plus b and y is equal to cx plus d for the two lines when a is the same as b, they are parallel. This a and b tells us the slope of the line. And perpendicular lines, for the perpendicular line, when the product of two lines, well actually there is a typo. The product of the slope of two lines is -1. The product of slope of two lines is -1, then they are perpendicular. So when you draw the perpendicular line, it looks like one line looks like this, and then the second line looks like that. And they meet with the right angle. That's a perpendicular. An example of this is like the y is equal to 2x minus 5 and y is equal to -1/2 x plus 1. When you multiply by 2 times -1/2, they have a -1 as a product, then these two lines are perpendicular. So in general, y equals like the mx plus b1 well, let's say the m1, m1 b1 m1x plus b1 and y equals m2x plus b2. Then, if m1 times m2 is equal to -1, if this is true, then the two lines are perpendicular. So, for the parallel case, the slope of the two lines are the same. In the perpendicular case, when you do the product of the two slope, we get a negative 1. That's the perpendicular. Now we want to determine whether the line L1, which pass through the negative 2, 1 and 4, 5, and L2 pass through the 3, 0 and 0, negative 2 are parallel. So how can I determine the parallel? So we compute the slope of the two lines. So let's find the slope. So L1 is a slope M1. L2 has a slope M2. Then M1 is y2 minus y1 over x2 minus x1. So this is x1, y1, and this is x2 and y2. So y2 minus y1 over x2 minus x1, which is negative 2. And this is a 4 over 6, which is a 2/3. So 2/3 is the slope for the L1. M2, the slope for the L2 is the same, y2 minus y1, x2 minus x1. Now this is x1 is a 3, y1 is a 0, x2 is a 0, y2 is a negative 2. So y2, negative 2 minus 0, x2, 0 minus 3. And this is negative 2, negative 3, which is a 2/3. Now they are the same. When they have the same slopes, they are parallel. And we're going to do the same thing, but we're going to determine whether they are perpendicular. So let's compute the slope M1. The slope M1 is the same, y2 minus y1 over x2 minus x1. Now, this 0, negative 3 is x1 and y1. 2, 0 is x2 and y2. So 0 minus minus 3 over 2 minus 0, which is a 3/2. So 3/2 is the slope for the L1. For the M2, the slope for the L2 is x1 and y1, x2 and y2. So negative 2, negative 0, 0, negative, negative 3. Which is negative 2 over 3. Now let's take these two numbers. And when you do they are not the same. They are not the same means they are not parallel. So let's test the two numbers. Let's do the product of these two. So 3/2 times a negative 2/3 is 3 and 3 cancelled out, and 1 and 1 cancelled out, but we have a negative here, so negative 1. The product is negative 1. Well, simply just M1 and M2. Since M1 times M2 is equal to negative 1, they are perpendicular.
when you took the points, for instance, on L2 -3, comma 0, and you write it into the equation, are you turning those numbers around all the time? Putting 0 minus 3, or what am I missing? You got 0 minus parentheses -3.
This is x1, y1, x2, and y2. So y2 minus y1, which is -2, -0. x2 minus x1, 0, -3, which is this. Always x1, comma y1.
Just got to remember the formula. Figure out how to write them in.
Yep. Now the average rate of change. So average rate of change is the slope. The slope is, the other way to define it is average rate of change in y per unit, change in x. So that is, the slope is basically the average rate of change. And we define this as y2 minus y1 over x2 minus x1. And that is average rate of change. So during the year 2000, the average person in US spent 866 hours watching TV. In 2004, the number of hours per person spent watching TV was 678 hours. Now we want to find the average rate of change in number of hours per year. So the average rate of change is from 2000, we have 866 hours, and in 2004, we have 678 8 hours. So obviously there is a decrease, right? So there is a decrease. So how we expect that when they are decreasing, we expect the slope is negative, or the average rate of change is negative. So average rate of change is the same, y2 minus y1 over x2 minus x1, which is 678 minus 866 over 2004 minus 2000, and this is a negative 47 if we simplify that. So there is a decrease, 47-hour decrease per year. So the average time per person spent watching TV decreased by 47. When this is a positive, it is obviously increased, but this is negative, so it is decreased by 47 hours per year from 2000 through 2004. That is the application of the straight line in some kind of the model. Any question about this? Okay. Now the 8.3. Equation of line and the linear model. So we'll discuss some formula for the line equation or the straight line. And the first formula is the point slope form. So we want to find like the linear equation is, well, if I write down here like that, y is equal to negative a over bx plus c over b. And when I simplify this, because we write this as just mx plus b, something like that. And this m, the first letter m, or the coefficient of x, is called as a slope. And this b is actually the y-intercept. So the typical form of the straight line is either this format or this format. That is a typical format. Now the point slope form is the equation of the line through x1, y1. So we have a 1 point x1, y1. Then we have a slope m. When you have these two information, and then we can find the line equation. The line equation is y minus y1 is equal to m, x minus x1. That is also very important. So when the slope m is given, and when you have one single point x1 and y1, we can write down the linear line, the linear equation. Now we will find the standard form of the equation of the line with the slope 1/3 and a point negative 2,5. Then we can plug in this. So m is equal to 1/3 and x1, y1 is equal to negative 2,5. So y minus 5 is 1/3 x minus minus 2. And this is the equation for the line. And we can change this just a little bit. So let's simplify this. So y minus 5 is, if we distribute, well, this makes a positive 2, this inside. If we distribute the 1/3, then we have 1/3 x plus the 2/3. And we can change this as y is equal to 1/3 x plus 2/3. And we can add 5 on both sides, which is a 5. So 2/3 plus 5 is a 2/3. The 5 is the same as 15 over 3, because we have to make the same denominator or the common denominator, which makes it 17 over 3. So this is 1/3 x plus 17 over 3. That is a simple format. Or we can also reduce this into y minus 1/3 x is equal to 17 over 3. Then we call this is a standard form. Although you don't need to worry about the standard form. At least if you can get up to this point, then you're okay. You're fine. Or maybe some of this format, but eventually you have to simplify this into this format. But anyway, that is a final answer. Y is equal to 1/3 x plus 17 over 3. That is a typical format. Although they ask to change this into the standard form, which is this, but we don't need to, typically. Now, line equation with 2 points. So, a line passed through the 2 points x1, y1 and x2, y2. Then we have the following. So, when you have a 2 points, you can find the slope, m. The slope m is y2 minus y1 over the x2 minus x1. Now, in the previous one, when you have a 1 point and a slope, we can write down the equation for the line. So if we use this, then we can rewrite this as y minus y1 is m, x minus x1. But here the m is the same as y2 minus y1 over x2 minus x1. And this is the equation, the line equation with the with the 2 points. Now let's use this. We're going to find the equation of the line which pass through the 2 given points, 5, 4 and -10, -2. And this is x1 and y1, and this is x2 and y2. So plug in, then we have y minus 4 is equal to y2 minus y1, which is -2, -4, x2 minus x1, which is -10, -5, x minus x1. Just plug into the formula. And this is a y minus 4 is -2, -4 is a -16, -10 and -5 is a why this is a 16? -6, sorry. -6 over -10 minus -5 is a -15 and x minus 5. And we can simplify by dividing by 3, which is a 2/5 x minus 5. Then let's distribute the 2/5, and we have a y minus 4 is 2/5 x minus 2/5 times 5. Then y is equal to 2/5 x. And we can simplify this as by dividing by 5, or cancel 5. -2 plus 4, which is a 2/5 x plus 2. And this is the final answer. Any question? I think we covered so many. So, and I think you need time to digest and study. So let's stop here for today.
Yeah.